All right, so we are going to continue with our lesson on curve sketching. And so we've talked about max and mins, we've talked about concavity. Now I want to talk about limits at infinity and asymptotes. We need to know where asymptotes are for us to be able to sketch these curves. But the limits at infinity is another way of saying end behavior. Okay, that's what this is. So last year, hopefully you learned about end behavior a little bit of different functions. So end behavior is basically what is happening when x is really, really, really big, or when x is really, really, really small, or really, really negative is what that means. Okay, so what's happening out there? And we know, like with polynomials, those are pretty easy, and we've talked about those. If it's an even polynomial, both ends either go up, up to infinity, or down, down, down to negative infinity. And if it's an odd polynomial, one end goes to infinity and one end goes to negative infinity, and it can flip based on if it's a positive or negative polynomial. So that's what we're talking about, is the end behavior on all of these, so that we'll know, okay, where is this thing going as x is getting really, really, really big. All right, so this first one, it says the limit as x approaches infinity of 3x squared over x squared plus 1. And I'm putting these through so that you can kind of look and see what's happening here. So here's the graph of it. All right, and you can see that as x goes to infinity, this is trailing off, okay, and it's going to basically a line that it's getting really, really close to, but it's never quite getting there. And that line is y equals 3, so it's getting really, really close to that. What do we call that? Those imaginary lines that things get really, really close to but never quite get to it. What is it? An asymptote. And this is what kind of an asymptote? A horizontal asymptote. Okay. Now, one question that comes up a lot, and let's just pretend that this isn't the graph, and could this cross that asymptote somewhere? And it's a trick question, actually. Okay, it could cross this asymptote, because what is it that I'm actually talking about? I'm talking about the end behavior, right? So it could cross this 1,000 times, but ultimately it's going to settle down as x gets really, really big, and it's going to get really close to 3. Or if x gets really, really small, it's going to get really close to 3. So what's happening kind of in the middle, it can actually change. And I don't know if you guys, I'm sure y'all saw these kind of graphs last year, where you had like 2 vertical asymptotes, and on this side it might have gone like that, and then on this side it might have gone to that, and your horizontal asymptote turned out to be 0 here, but in the middle it just crossed right through that thing. Do you remember graphs like that? Okay, so it can happen, but you got to remember what we're talking about are the ends, the end behavior. What is this thing doing on the end? All right. Another way to look at this is, so I talked about this being a horizontal asymptote. Okay, another way you can do this is numerically, and we've talked about how we do these things numerically. So if I plug in negative 100 up here, I get something really close to 3. If I plug in positive 100, I get something really close to 3. If I plug in 1,000, it's going to get even closer to 3. Negative 1,000, closer to 3 again, until ultimately we can rest assured that it's probably at 3. All right. So has everybody kind of got the big idea of how we do these things? Okay. So horizontal asymptote, the definition of it. Can y'all see this? Okay. The horizontal asymptote, if the limit as x approaches infinity of f of x equals some number, and the limit as x approaches negative infinity equals some number, then that number is a horizontal asymptote. Okay, that's mathlish for all of that. Okay, and I think y'all have a pretty good idea what a horizontal asymptote is already. All right, limits at infinity. So this 1 over x, as x approaches infinity, is equal to, anybody know what that is equal to? 1 over infinity. 1 over something really, 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 really big. It gets very, very close to 0. Your limit is 0 there. 1 over x squared. The limit as x approaches infinity of 1 over x squared. What is that? 1 over infinity squared, which would be what?
Really, really big.
Yeah. Okay. So the actual technical term, they have a theorem for this. It's called the little big theorem. Okay. Little big. So if you have something little over something big, or even something big over something bigger, these things equal 0. Something little over something really big equals 0, especially if this is getting big without bound, and this is getting bigger without bound. Okay, it is equal to 0. So that's called the little big theorem. There's also a big little theorem. What do you think the big little theorem is? Something big over something little. Yeah, it'd be infinity, or negative infinity. All right, so this example right here. 2x minus 1 over x plus 1. And this is as x approaches infinity. So if I plug infinity in up here, I get 2 times infinity minus 1, which is equal to what? It's infinity. And infinity plus 1 is infinity still. So I get infinity over infinity. This is called indeterminate form. Okay? What else have we called indeterminate before? 0 over 0. So indeterminate doesn't just, it's not just for 0 over 0, which it is, but it's also infinity over infinity, or negative infinity over negative infinity. So those are all indeterminate forms. Okay, so the way that you're going to be taught to do this is you're going to divide through by the largest power. Okay? Largest power of x. And so what is the largest power of x here?
1.
X to the 1. So this is going to be the limit as x approaches infinity of 2x over x minus 1 over x. All of that over x plus 1 over x. Everybody with me? What I just did? And is that legal, what I just did?
Yes.
I basically multiplied 1 over x over 1 over x. So what did I actually multiply by? 1. 1 over x reduces to 1, right? So I can multiply by 1, and that's what I did here. Multiplied everything by that. Okay, let me write that up here. 2x minus 1 over x plus 1 times 1 over x over 1 over x. That way you know what I did. Okay, so this reduces to 2 minus 1 over x over 1 plus 1 over x. And according to the little big theorem, what do I get? 1 over infinity is what? It's 1 over something really big. It's 0. So this is 2 minus 0, which is 2. 1 plus 1 over infinity. So 1 plus 0 is 1, and that equals 2. So what does that mean 2 is? It's the asymptote. It's a horizontal asymptote. All right. Do I have any other asymptotes on this 2x minus 1 over x plus 1? Do I have any other asymptotes? I don't have any other horizontal asymptotes. Do I have any other vertical? Okay. When the bottom is 0 and the top is not, I get an asymptote. So that's when x plus 1 equals 0. That's when x is equal to negative 1. Plug negative 1 back into the top. So that's 2 times negative 1 is negative 2, minus 1 is negative 3. So negative 3 over 0 would be an asymptote. So looks like that. The graph actually looks something like this. Okay? Any questions about that? Y'all want to learn another little trick on doing limits for these indeterminate forms?
Sure.
Okay. When you have indeterminate form of a limit, the limit as x approaches infinity of this turned out to be infinity over infinity. If you want to know what the limit is, take the derivative of top and bottom separately. Put them on top of each other. What's the derivative of 2x plus minus 1? 2. What's the derivative of x plus 1? 1. Plug in your infinity there for x, which I don't have any, I get 2. Okay, so that's called L'Hopital's rule, and we're going to talk about that at the end of the year if we have a little more. Some of you had already learned L'Hopital's rule. You were talking to me about it.
Earlier. Oh,
That's
yeah, I remember
that's
that.
what that is. So that's something that is not a part of AP Calculus AB, but it will be what you do next year in college. Okay, look at these. All right, so everybody with me. I'm going to try to tie all this together. Determine limits at infinity for rational functions. So here we go. Here we want to plug in infinity. I get infinity over infinity squared, which is infinity over infinity. That's indeterminate. So I'm going to divide everything through by the largest power of x, which is x squared. So this is going to be the limit as x approaches infinity of 2x over x squared plus 5 over x squared over 3x squared over x squared plus 1 over x squared. So this turns into 2 over x plus 5 over x squared over 3 plus 1 over x squared. And what do I end up with? When I plug in infinity, 2 over infinity is what? 0. 5 over infinity squared is, so that's 0 over 3 plus 1 over infinity squared is 0. So what's my horizontal asymptote there? 0. Y equals 0. Okay, let's do this next one over here. What's my largest power this time? It's x squared again. So we're still doing to infinity. This is going to be, I'm going to multiply 1 over x squared over 1 over x squared by everything, which is 2x squared plus 5 over 3x squared plus 1. And I'm left with 2x squared over x squared plus 5 over x, 5 over x squared over 3x squared over x squared plus 1 over x squared. All right, so now that's the limit as x approaches 0. So x squared over x squared does what? They cancel, so I'm left with 2 plus 5 over x squared. That's 5 over infinity squared is what? 0. So 2 plus 0. And then 3 plus 1 over infinity squared. So that's 3 plus 0. So 2/3. All right. Next one. What's my largest degree this time? X cubed. So I'm going to multiply everything by 1 over x cubed over 1 over x cubed. And this goes limit as x approaches infinity, 2x cubed over x cubed plus 5 over x cubed over 3x squared over x cubed plus 1 over x cubed. That goes to 2 plus 0 over 1 over infinity, or I'm sorry, 3 over x. So 3 over infinity is what? 0. 1 over infinity cubed is what? So 2 over 0. So that's a problem. Okay? So what does all this mean? All right. When the largest power is in the denominator, okay? When it's the biggest, the limit is equal to 0. When the largest power is in the numerator and the denominator, in other words, they're the same, the limit is the ratio of the leading coefficients, 2/3. When the numerator has the largest degree of x, then your limit does not exist. That's unbounded behavior. Okay, and that's like a slant asymptote, or there's all kinds of different asymptotes. But so that means when limit is equal to 0, it means your horizontal asymptote is y equals 0. When it's the leading coefficients, in this case, horizontal asymptote at y equals 2/3. This one has no horizontal asymptote. Okay, so that's the quick and easy way of doing that. Okay, so